Girls, yesterday we started with circular motion and we defined the meaning of uniform circular motion and we talked about the properties of uniform circular motion. Then we said that we have something related to circular motion. We talk it and we call it tangential velocity. We said we call it tangential because at any point the velocity vector is tangent to the circle. It means it touches the circle at one point only. Okay? And this tangential velocity has a formula. What is the formula? It is 2 by r over t. 2 by r is the circumference of the circular path, and t is the period of uh, this motion. Okay, now we want to talk about if an object moving in a circle at any time, the object leaves this circle. Why? For example, if the force that provides this circular motion stops, what will happen to this object? What do you think? How the object will move toward the center of the circle, away from the center of the circle, in a straight line, toward up, to the right? I will tell you. Let's read together, then I will explain. Forces are responsible for creating circular motion, for sure. We need a force to create a circular motion. If the forces causing circular motion stop acting, the object will leave the circular path. When this happens, the tangential velocity becomes the initial velocity for the object's subsequent motion. If no forces act on the object will move in a straight line, matching the tangential velocity at the time of release. If another force acts on the object will become subject to the new force. Look here to understand. Here I have an object moving in a circular motion. At any moment, the force that provides this centripetal force, circular motion stops. So what happens to the object? Let's say the object here, at this moment here, while it's down, the force disappears. What will happen to the object? The object will move with the same direction of tangential velocity at this point. Now at this point, you have to know how to draw this vector, by the way. At this point, if the object is moving counterclockwise, for example, and I ask you to draw for me the direction of tangential velocity here. What you're going to do is just to draw a straight line that touches the circle at one point. Toward where? To the right. The object will continue moving the same direction as tangential velocity at this point. So it will continue moving here, for example, to the right. Okay? To the right. Here, in a case that I don't have forces, I am in a place that has no air resistance, no friction, no force of gravity, the object will continue moving the same direction. But in real life, we don't have that. Why? Because we know that we have force of gravity, for example, on Earth. So what will happen? The object, here's the direction of tangential velocity, will move a little bit straight, then will go toward down. Why? Because there is another force now acts on the object. At this moment, the centripetal force, the one that causes the circular motion. We are going to talk about centripetal force later in this chapter. Here, at the moment the centripetal force disappears, there is another force here. The force of gravity will take the object toward down. Look how parabolic shape or a curve shape. Okay? Good. I hope that this thing is clear because it's very important always in the exam. I can draw the place of the object anywhere. Then I ask you to, if the force disappears, draw what happens to the object, where the object will move. You have to know, for example, if the object is here, what to do? You just draw the tangential velocity this way, so the object will move toward up, then will move toward down. You can't say from here direct it will move toward down. No, it will move a little bit toward up the same direction as tangential velocity, then will go toward down. Let's start talking about acceleration. We said from the beginning that we have acceleration in circular motion. Why do we have acceleration? Not because of speed, it's because of velocity. Because velocity is changing. How velocity is changing? Because direction is changing. So when direction changes, it causes velocity. So velocity changes, it causes what? Acceleration. We call this acceleration centripetal acceleration. The meaning of centripetal, center seeking. Why center seeking? Because at any point in the circular motion, any point of where here the object is here or here or here, the centripetal acceleration always toward the center, always. Okay? Circling objects have a changing velocity vector. They are continuously accelerating. This type of acceleration is known as centripetal acceleration. Look, girls, in circular motion, the terms they are not the same as before. So velocity, we call it tangential velocity. Acceleration, we call it centripetal acceleration. Okay? Centripetal means center seeking. Centripetal acceleration is directed toward the center of the circle. Centripetal acceleration has another name, radial acceleration. Here is centripetal acceleration, the formula for it equals v squared tangential speed over, or tangential velocity over what? Radius of the circle. So look here, this one is very important. Why? Because I can draw the object at any place here in the circle, for example here, and I ask you to draw the direction of the centripetal acceleration and the direction of tangential velocity. You have to know. I will only give you the place of the object and I will give you the direction of motion if it's clockwise or counterclockwise. So easy. The tangential velocity with a ruler you just draw a straight line touches this circle at this point exactly, and the centripetal acceleration is toward the center of the circle. Good. Let's solve an example about tangential velocity and centripetal acceleration after we took the two formulas. Determine the acceleration of an object experiencing uniform circular motion. It is moving in a circle with a radius, so the radius is given and it equals 10 meters. And a frequency of 0.25 Hz. Okay, first of all, they are asking for acceleration. What do we call this acceleration? Centripetal acceleration. Let's write the formula for centripetal acceleration. Here is it. Equals v squared over r. The radius is given. V squared is not given. So what we can do? We want to find the tangential speed. So we write the formula for tangential speed. 2 by r over period. Okay, I have the radius, I don't have the period. How can I find the period? What I have, I know that there is a formula relate period with frequency. Frequency is given why? To find the period from it. So the first step to do is what? To find the period. Then I substitute it in the tangential speed. Then I substitute it in the centripetal acceleration formula and I will find the answer. Okay, so girls, always in these questions, look, they're asking for what? Write the formula for this thing and then see, we're looking for what's here in this formula and you decide what to do. Here are the steps of solving. The first thing, we find the period by dividing 1 over frequency. Here's the answer for second. We substitute the period in this formula. 2 by r over t. Here r is 10. So here's the final answer, 5. Sometimes here in SAT exams, they just leave it in by no, they don't write they don't multiply the answer with 3.14 because, as I said before, that SAT physics exams, it's not allowed to use a calculator. That's why. But for you, you can write the answer, the final answer without by. Okay, 5 times 3.14, and then centripetal acceleration, and the answer is 2.5 pi squared meter per second squared. And to see what's the answer exactly, 2.5 times pi squared, the answer is 24.7 meter per second squared. Okay? Okay, girls. Now we have here extra questions about centripetal acceleration. So I will solve now with you question 1 and 3. Questions 2 and 4, they are homework. I hope that you solve them very easy and direct. Just write the formula and substitute. And also I prepared some questions about what I explained today and yesterday. I hope that you answered these questions.